If you're responsible for the profitability and reliability of an industrial facility, you already know that energy is an important cost that you need to consider, and you may even believe that to some extent that can be controlled. But what's less obvious is this: finding, proving, and delivering real energy savings that help reduce that cost is actually not that simple. It's tempting to think that energy efficiency is just, well, let's just replace the lights with LEDs, or let's put a VSD on this motor, or variable VFD or VSD, variable frequency drive, variable speed drive. But in practice, the highest value opportunities sit inside motor-powered systems like pumps and fans, the whole system, not just necessarily the pump itself, process heat and steam, refrigeration and cooling, and there's interdependencies amongst these different types of energy usage. And so today I want to show you how you can get audits done that will hold up under scrutiny from the CFO, why energy auditor expertise matters, and how the investment grade energy auditor IGEA credential helps in you being able to pick a capable professional for undertaking energy audit. I also want to highlight why an independent third-party review, such as 80/20 Greens, is a smart safeguard before you commit capital to a project. Hi, I'm Bruce Rouse, and you're at the Sustainability Education Academy. So what's at stake here? Well, most plants have known unknowns of energy wastage. Things that you suspect, whether a pump has been throttled too much, or compressors are not well sequenced, or there's set points that could be optimized. And then there's also the unknown unknowns, which could be control interactions, hidden base loads, heat recovery opportunities that no one's measured. Now, the stakes in trying to address these issues are financial. Well, credible savings that clear your hurdle rate and actually show reduced energy costs on the profit and loss. Then there comes the operational benefits of energy efficiency, which can be improving reliability, possibly improving the quality of the products you produce, potentially also assisting with safety, so you don't get any nasty surprises from undergoing a cheap fix that causes problems. And then there's governance. Of course, if you want to put forward a capital works budget, that needs to be approved. And so you need investment grade logic that your board will respect, and measurement and verification undertaken throughout to prove that the actual expected energy savings have been achieved. So an industrial energy audit is not just a residential or office audit scaled up. It's a different game. The prize is real, but you need the right playbook for doing it and also the right kind of coach for doing industrial energy efficiency. So why are industrial energy audits hard? Well, industrial plants, as you know, I probably don't need to tell you this, they're complex systems. Your motor-powered items, such as pumps and fans, will behave non-linearly, although other things like crushers may behave in a linear fashion where energy consumption is directly proportional to speed. Duty cycles can vary with production, again, sticking with motors and pumps. So a variable speed drive might help on some loads, or in other loads it actually could even possibly increase energy use. But I have actually seen cases where VSDs have been wrongly specified and caused energy use to increase somewhat counterintuitively. Now then, if we look at process heat and steam, which is a large energy use in industrial sites, you're looking at combustion efficiency, condensate return for steam systems, heat recovery, good maintenance practices to prevent fouling. You also need to look at control strategies that interact well with the production scheduling and don't impair production. On refrigeration or process cooling, well, there's of course seasonal profiles to consider. There's part load efficiency issues and problems with equipment needing maintenance, like condensers needing to be maintained. And also then there's nuances around changing set points and the knock-on effects that can have. Now, compressed air is a notorious money sink due to leaks and maybe pressures being gradually put up higher depending on the needs, and maybe poor storage or controls associated with compressed air. And then if the controls and sequencing in your control systems or SCADA systems are not well done, that can actually quietly undo the best hardware decisions. So because these systems interact, a simple change can actually move costs around. Relieving a bottleneck in one part of the factory could actually increase upstream energy. If you lowered a pressure too much, say in an air compressor, that might trigger quality deviation. Changing a set point might increase compressor cycling. So there's many complexities that need to be considered, which is why an investment grade audit endeavours to measure, model and risk assess, stress test before actually putting forward a recommendation for you to consider. So the good news is that complexity is an opportunity. Often in complex systems, there's very good opportunity to save energy. Often the harder the system, the potentially higher the savings that can be. Only if you tackle it with expertise and I think some patience as well. So what are some of the myths that waste your time around industrial energy efficiency? And I want to talk about 4 things. Maybe you've heard of these, maybe you haven't. And possibly they're a little bit too simplistic, but some of them are, well, there's, a vendor may say, just put a VSD, a variable speed drive in this, or variable frequency drive, VFD, and you're going to save 50 to 60% on your energy use just by, cutting the speed by 10, 15, 20%. Well, VSDs can be excellent, but savings really depend on the load profile and the control strategy and the minimum speeds and the system hydraulics and aerodynamics and set point management. And it's amazing how many facilities you go into which have got a VSD and it's just set to the mains frequency, not actually delivering energy savings in actual fact slightly increasing energy use because of the power draw of the VSD itself. Some of the best savings that I've helped achieve at sites have had VSDs installed, but they haven't quite been optimized they haven't actually been optimized at all in order to maximize the savings that can be achieved. So many facilities, yes, do have these VSDs, but realistically, savings for appropriately applied VSDs on pumps and fans often land in the 10 to 30% range, which is well below the large range that many may claim of 50% or higher. And cherry picking extreme best case examples sets the wrong expectations when you're implementing energy efficiency. Now, perhaps someone may come into you, well, say HVAC is possibly your largest energy user in industry. Well, in fact, it depends. If you've got clean room facilities, HVAC, yes, that can need a lot of good temperature control. HVAC can be a very large energy user in an industrial facility. But often process heat, refrigeration, compressed air, and specific motor powered systems actually dominate. Audits done by someone who only has HVAC expertise can miss the main game. A second, although I'm hearing this a lot less often, in some facilities it still may be true, is that lighting will transform your energy bill. And some industrial facilities with very old legacy lighting, perhaps more facilities with packaging or so forth where the energy use may not be that high otherwise, LEDs actually do cut energy use dramatically at the fixture level. But across the whole site, the lighting is normally a relatively small proportion of total site energy use, so the savings is going to be quite small. So overselling LEDs risks prioritising just a very small slice of the pie, while large opportunities sit untouched. So it's quite common for energy auditors who just have a narrow area of expertise, whether that's lighting, whatever, to come in and just focus on what they do and miss the rest of the pie. And then another common one that really bugs me a lot actually is the assumption that you just need to upgrade the motors from, say, an IE2 motor to an IE3 motor, under the assumption that motors are inefficient. Well, most of the induction motors in a facility will already be pretty efficient. Going from IE2 to IE3 may only save you a couple of % of energy, 1 or 2%. It's not much. Usually the big wins actually come from system efficiency, not just looking at motors themselves, but looking at the system that motor helps power. And it can involve changing pumps or fans to ones that are better suited to the duty point, pressure and flow matching, eliminating throttling or bypassing. So when you're looking at this, don't just focus on the motor, focus on the system that the motor powers, and the motor efficiency opportunity is actually just a small opportunity in relation to the other opportunities for that system. So the bottom line is that industrial energy efficiency is beneficial, but it's not necessarily easy to achieve. The credibility comes when you've got a realistic baseline, solid measurements, system thinking, and reasonable knowledge of the technologies that you're assessing and what the real potential for savings is. Not the potential that may be quoted by a supplier who's just trying to sell their equipment, for example. So what does an investment grade energy audit look like? Well, a credible audit will follow a disciplined sequence. And here's several short points that I'm not going to explain in full detail, but scoping and stakeholder alignment at the start is the first thing you need to do really well. It needs to clarify the operational constraints, what safety requirements are essential, the maintenance windows, what are the production rhythms, but also understanding the CapEx process, the budgetary approvals process, and ensuring that you're really aligning well with the organisational objectives as an auditor. You need to look at this. And you need to agree on success metrics, like what's the net present value that we need to achieve, or the internal rate of return we need to achieve. How big a project, how much are you willing to spend? What's the payback? What's your risk appetite? What does really investment grade mean for that organisation? Then there's the second item is to look at data and determining a baseline. So as a bare minimum, you need 12 months of electric fuel gas usage water if relevant, and production and throughput data. 24 months is actually much better than 12, usually a lot better. You need to be pulling data out of any SCADA system, any building management system, any high-level machine interfaces wherever possible, and start to build a time-aligned baseline, which can be quite a lot of work. You need a metering and measurement plan, which may involve temporarily deploying power loggers or ultrasonic flow meters, pressure or temperature sensors, data loggers, where the currently installed metering is actually insufficient, or you just want a quick snapshot of how something is performing, an important system is performing, say, for over a week. You also need to plan to be capturing representative operating states. What's the peak season, the shoulder season? What happens out of shifts? What happens when you're cleaning equipment, etc. So you're getting a really good understanding of the sites. Then there's the walkthrough of the site and mapping. A walkthrough implies something fast actually can be quite detailed, and you can spend a lot of time just looking at one item of a plant, but it needs to be tracing how energy moves through the site, looking at your motor powered equipment such as fans, compressed air, refrigeration cooling, looking at the process heat and steam, dryers and ovens, process lines, noting the control points, the set points, any bypasses, any valves or dampers that seem to be wasting energy, noting operator interventions, identifying maintenance concerns. And then there's a hypothesis testing, where ideally, if a good auditor will be proposing a hypothesis, if we did this, for example, if we reduced the pressure by 0.2 of a bar, does the reject rate rise? If we improve the condenser approach temperature, what percentage will our chiller kilowatts per ton or kilowatts per kilowatt refrigerant drop? You may run short trials or high resolution measurements to confirm or kill ideas. And I'm a big fan of data to really understand how a system works well, and then you're going to be much more confident in your estimates of savings recommendations. Then there's the options analysis. Well, which option do we choose? And in what sequence? Where do operational adjustments fit in, such as set points? What are the control logic changes that we are recommending? Where do variable speed drives fit in? Where do we do heat recovery? How do we manage leaks? And then what capital equipment upgrades do we need to consider? Capital changes, whether that's redesigning a system or just updating equipment. And then ideally you'd be quantifying each with a range, band of savings range, erring on the conservative side, although also striving to be accurate and not being too conservative. If you look at the CapEx and OpEx, any risks associated around production or quality, or risks with the implementation of the project itself, interdependencies. Then you're going to be looking at financial modelling for executives, like modelling cash flow, conservative or likely or aggressive cases, doing some sort of sensitivity analysis around energy pricing, utilisation of equipment, maybe the production mix, and looking at the maintenance impacts. An investment grade audit kind of should come up with a prioritised list of actions, some no regrets quick wins, some mid caps, high return, and then some strategic projects that maybe have longer term benefit. Then there's the implementation plan, which identifies, well, who's owning this project? What are the timelines? What is the procurement approach? Are you going to go to tender? Are you going to just appoint an existing contractor you trust? How are you going to do it? What's the commissioning plan? What's the measurement and verification plan? What are the performance guarantees? Where they're viable? Do we want performance guarantees? Then there's the measurement and verification, which is defining baselines up front and probably developing some sort of model that relates energy use to some independent variables. And M&V protects both finance and operations by showing actually what actually happens. So this is the standard, covering all those points that I've just covered, that you want to expect from someone operating at an investment grade level. And that's what the IGEA, the Investment Grade Energy Auditing certification, is aiming to kind of formalise. So why does the IGEA certification, Investment Grade Energy Auditor certification matter when you're choosing an energy auditor? So this is a certification offered by the Sustainability Education Academy, and it's designed to lift the bar on auditor competence and rigour. In order to become an IGEA, you actually have to submit an energy audit report, which gets assessed in a lot of detail, and not just answer a set of multiple choice questions. So an IGA certified professional has demonstrated in submitting an audit to be assessed that they can develop a credible understanding of baseline energy use and develop a good energy use breakdown, where energy is used at the site. They can focus on system opportunities, such as motor-powered items like pumps and fans, refrigeration systems, compressed air, cooling systems, heating systems, and not just shallow checklists. So they're not just doing a checklist equipment replacement, they're actually thinking wide about the whole system. They can translate technical findings into a business case that the board can understand with realistic savings and risk framing. They have a detailed technical understanding of the equipment that they're operating and the many opportunities that are associated with a lot of types of equipment. Sometimes an energy auditor who's inexperienced will find one opportunity when an experienced energy auditor might find 10 opportunities. So when you're shortlisting energy auditors, a good question to ask is, are you IGEA certified? And could they show, for example, the report they submitted for their IGEA exam, which ultimately passed, showing the energy use breakdown, showing the savings measures identified, the cost and benefit, and even showing, ideally, what the actual savings were based on measurement and verification. Do they prioritize the significant energy use, the large energy uses first, rather than chasing familiar but minor loads? Large loads would be process heat, maybe refrigeration, so on. And then what's the measurement and verification plan and who signs off on the success? Ask if they understand your production constraints and quality tolerances. So the IGEA is a kind of a fairly strong, quick filter, and it's not going to replace due diligence, but it improves your odds of hiring someone who delivers investment grade work. Now I want to talk about why independent third-party review is smart, undertaken by 80/20 Green. So even with a capable auditor, a second pair of expert eyes can protect your CapEx and timeline. So you want someone who's really expert. And that's the purpose of 80/20 Green's Energy Audit Review Service, is to check that what's on paper will actually stand up in practice in front of your board. So an independent review will typically test for baselines and data integrity. Do the numbers make sense? Is any normalization fair? Is seasonal effects configured? Very importantly, is double counting avoided and interactions between different savings measures done well so that the savings are not overstated? And it's a very common problem for auditors to overstate savings. What about the feasibility and reliability of the upgrades? Will the control changes stay stable across the shifts and production mixes? Are there any cybersecurity or safety implications that need to be concerned? How real is the budget? Do we have quality supply quotes or just rough estimates? Have we looked at the disruption due to the implementation? Have we looked at the whole range of issues associated with capital costs, from project management fees through to costs associated with removing existing equipment, disposing of it, dealing with any latent defects at site, and so on? And then in terms of the ongoing cost of new equipment, any new equipment that's proposed, what will it cost to maintain and operate? Has that been considered? And then it's always good, although it's not necessarily part of an energy audit report, but it's accompanying an energy audit report, is that there's been good consideration for measurement and verification. And, can you prove to the finance people who've put up the money that the savings have occurred? Do you have a clearly defined MNV? And then finally, prioritization. You look, does the portfolio of measures reflect the hurdle rate of the client, the energy user? What's the risk appetite? What are the downtime realities? So by using an independent review before tendering for major CapEx, or as a quality control step after you receive an audit from any provider, whether they're IGA certified or not, is inexpensive insurance against rework, credibility loss, and delays. And let me just give you an example of one such project recently where an energy auditor estimated a 2 million CapEx budget. And so they went through the arduous process of developing a detailed specification, putting it to tender. And then when they went out to tender, the prices that were coming back were 4 million, twice. Now that's a failure, I think, in the energy audit, and perhaps in an independent review, a thorough independent review should have identified that, and thus, the loss that energy user incurred, because ultimately I don't think they proceeded, would not have happened. I want to now give you a bit of a feel of what realistic savings opportunities may be. Now, this is just very broad form, they're very site specific, but I'm going to give you some ranges of what could be credible. And if you're getting numbers above these, perhaps you need to raise the antenna a bit and think, hey, maybe this audit's not quite right. These ranges should be reasonably good, but again, they're very site specific. I cannot emphasize much that, energy audits, the savings are highly site specific. So if you're looking at pumps and fans or motor powered items, there's many things to look for, such as throttling or bypassing. Is it operating at the correct point of the duty curve? Are the impellers oversized? How's the speed controlled? Is the control loop stable? Some possible interventions would be impeller trimming, or even just putting on a VSD and slowing it down a bit, or having a control strategy where your speed varies through a variable speed drive, variable frequency drive, VFD. Maybe better sequencing, better set points. Maybe some pressure sensor-based control to modulate speed. such as on air handling units or on pumps. The typical savings could be 10 to 30% on a system when applied correctly. Outliers exist, but that's a typical range. With compressed air, so leaks is a common problem that often needs continuous attention. Therefore, there's actually not just a once-off item to fix. It needs more of an internal change about how you manage the leaks and how you continue to monitor them. And possibly that could be wasting 15 to 25%. The pressures may be set higher than needed. There could be poor storage, poor air distribution, missequenced compressors, inappropriate use of air where you just say using air to blow down, compressed air to blow down something. So the interventions are obviously leak management programs, pressure reduction, proper size storage and controls and distribution of air. Eliminating, what I really like is to eliminate the use of compressed air altogether. So can you use blowers or could you use mechanical actuators? And the typical savings might be 10 to 30%, sometimes higher with energy substitution. But often you might hear suppliers saying 45%. Well, that's probably a bit too high. Process heat and steam. What to look for? You can look for losses in the flue stack, poor heat recovery, condensate losses. Steam traps are a really common problem. Steam systems tend to inherently become less efficient quickly. Fouled heat exchangers, over temperature set points, using steam for the wrong function when you could be just using hot water instead of steam. Lack of insulation, duty mismatch. There's a whole lot of stuff there to do with process heat and steam. So some of the interventions are steam substitution or heat substitution with alternate sources like hot water instead of steam, use of economizers or heat recovery, improved controls, making sure that the burner is well tuned, insulation, improving condensate return, right sizing. So typical savings might only be as low as 5%, maybe 20%, depending on the fuel use. And sometimes you get more with substantial heat recovery and scheduling changes, but often sometimes capital expenditure can be quite high. Then we look at refrigeration and process cooling. So you can look for things like condenser fouling, especially with systems with cooling towers, poor approach temperatures, for example, your condenser water return temperature being too high, high head pressures in the refrigeration system, again, signifying probably high temperature somewhere, too high temperatures, ineffective use of free cooling, economy cycles and sometimes you can use outside air effectively for this, or capture heat or cooling from another process, poor sequencing, non-optimal set points. So the interventions can just be the boring stuff like improved condenser cleaning, maybe looking at some inbuilt cleaning systems, effective water treatment for these cooling towers, having floating pressures depending on ambient conditions or load, improved sequencing, variable speed drives, thermal storage, heat reclaim. Again, it's quite complex, but typical savings could be 5 to 20%. And then we look at lighting. And obviously this is a little bit simpler. You can look for old kind of lights, like high intensity discharge lights, high pressure sodium, metal halide, and maybe even mercury vapor lights, very old now and out of date. The continued use of fluorescence, look at over illumination where controls are poor, so lights stay on for too long. And the interventions can be LED lighting plus controls, noting that LEDs ain't LEDs. There's different qualities of LEDs and there needs to be some effort put in the specification of the LEDs. The typical savings are actually very large at a fixture level, but site level impacts may be small because lighting is often a small share of the industrial consumption. Then we look at controls and scheduling. You can look for equipment running during breaks, cleaning, just for convenience, operating overnight, operating on weekends, redundant safety margins put into set points, temporary manual overrides that become permanent. And interventions here can be set point rationalization, interlocks, improved. I'm a big fan of manual on, auto off control, scheduling of cleaning and hygiene to keep equipment in good condition, alarming on control drifts. So savings might be in the range of 5 to 15%. So these are just, again, indicative savings, maybe high, possibly a little bit higher. Operations and maintenance. Well, this is, again, getting to the nuts and bolts. So you've got filters, you've got steam traps, you've got strainers, you've got belt drives, you've got fouling, you've got leaks, you've got actuators, and then you've got maintenance cycles decoupled from performance indicators. So interventions could be condition-based maintenance aligned to energy KPIs, and instituting some operational KPIs may come back to maintenance, improving maintenance. So the savings might be 2%, maybe up to 10% with minimal capex, but often some investment in operator training and engagement. Now, you might notice the large savings come from system level changes and not just a catalogue of different items of equipment replacement. So this is what you should expect from an investment grade audit and what an independent reviewer should pressure test. So how do you brief your energy auditor for success? So you can make or break the audit outcomes by how you brief the energy auditor. You can define success in financial terms. You can provide hurdle rates, preferred paybacks and capital constraints. You can be quite specific about the level of detail you want put into cost estimates, and you may even insist on some guarantees. You could share the production realities. Give them as much data as you can. Shift patterns, product changeovers, quality tolerances, seasonal effects, planned expansions, and consuming this data. You need to open the data door. Give them bills, give them interval data, give them SCADA trends, give them access to the SCADA system, give them the tag names for the different equipment used in the SCADA system, give them maintenance logs, show them data and rejects, give them ambient utility data. And ultimately, a good auditor is interested in the business improvement, not just the energy improvement. So things that you might think are a bit tangential could actually be really useful for an energy auditor. Start to think of system changes that may give some really valuable savings at the site. Now, you should be insisting on measurement, and if a major recommendation lacks real measurements or a test plan, it's not really investment grade. And as a person who assesses in energy audits for this investment grade energy auditor certification, it's frustrating for me when I see someone has put forward a measure that is based on estimates, not on actual measurements. Measurements are critical in order to be able to substantiate the savings calculations. Also ask for portfolio thinking. Ask your energy auditor to deliver both some quick wins, plus those in the mid capex range, and plus those which are more strategic with longer capex. And each showing how M&V might be undertaken and the risk range. And then plan an independent review. Signal up front that a third party will review, such as 80/20 green, and this should elevate rigour from the start. So we've actually got an entire course in the Sustainability Education Academy on commissioning, managing and reviewing an energy audit. And you may want to take that course if you're about to commission an industrial energy audit, just so you're better equipped to manage the auditor and get a good outcome for both you and the auditor. So let's just give you some mini kind of case examples. So here's an example. There's a pump which was heavily throttled. That means valves reducing the flow rate of water. So there was a process water loop that ran a 45 kilowatt pump at a constant speed with a throttle discharge valve. And logger data from the SCADA system showed the valve set at 55 to 65% closed, most trimming the impeller on that pump and changing the control logic to maintain set point via speed with a flow bypass for safety. So there's a bit of capital cost involved, but system kilowatt hours dropped by 18%. And flow stability improved and pump vibration fell, extending pump life. Let's look at a compressed air example. A common one is that the pressure is a bit too high. The main header was set at 7.5 bar for safety, or 750 kPa. Trials showed and end users were stable at 6.8 bar or 680 kPa. So a leak campaign plus pressure reset and adjusting the storage. Again, not necessarily a cheap project, but it did reduce compressed energy use by about 22% and extended the maintenance intervals, reducing maintenance costs. Furthermore, a few applications where compressed air was just used for blowdown were replaced with low pressure blowers, and that further cut compressor runtime variance. Refrigeration, so that the condensers were dirty and the head pressure was fixed the year round. So cleaning plus enabling of floating head pressure and smarter sequencing got a 12% energy saving with no production risk, and it was confirmed by M&V undertaken over a season. And then a process heat recovery example, an exhaust stack temperature profiling revealed there's a lot of heat going up that exhaust stack and being wasted. So a compact economizer, which was used to preheat makeup water, cut fuel usage by about 9%. And the payback was pretty reasonable on that. Controls ensured recovery bypassed was during low load or maintenance periods. Okay, so each of these improvements was measured, modelled, piloted, and then implemented. Good investment grade behaviour. So what's your action plan? I'm going to give you 6 points here. Firstly, shortlist auditors who've got industrial experience and also ask if they're IGEA certified. Secondly, scope for an investment grade. Look at the baseline and measurement plan, system focus, and also ask for M&V, which is often independent of the audit, but it's a good thing to ask for. Insist on realistic ranges of savings. Ask for a range of potential savings, not just a single point savings with uncertainty bands. If the low end of the range satisfies your financing requirements, then you've probably got a pretty good project, presuming that the investigation has been thorough. Prioritise your largest lows, such as process heat, refrigeration, compressed air, motor power systems. Fifth, book in an independent review and 80/20 green. Have 80/20 green sanity check the audit before you commit to capital expenditure. And sixth, as I mentioned right at the start, lock in measurement and verification so that finance sees savings and operations keep those savings. Okay, So just to kind of wrap up now, so industrial energy efficiency is beneficial, but it's not inherently simple. The difference between just a report that ends up on the shelf and gets no action on, and one where savings are bankable, is expertise. It's also dependent on you engaging well with the energy auditor and having your requirements clearly specified as well as your expectations. Choose an investment grade energy auditor, IGEA, certified by the Sustainability Education Academy, to do the work to an investment grade standard, and use an independent review like 80/20 Greens to validate it before you spend. You can also consider learning more about how to commission, manage and review an energy audit by undertaking a short and inexpensive course in the Sustainability Education Academy on that topic. So if you're ready to turn complexity into profit, ask if the energy auditor is IGA certified. If you haven't done an energy audit report before and you're not that confident about managing the energy audit, by taking the course Commissioning, Managing and Reviewing an Energy Audit. And then thirdly, I'd say line up a review by 80/20 Green so that you've got good confidence before you commit to spending and implementing the audit recommendations. So look, I'd love it if you could just drop some comments in about this. What are your pain points in relation to industrial energy efficiency? And if this video has helped you, please like and subscribe to this channel, because we'll continue to try to provide pragmatic guidance on energy efficiency.